So here we are looking at a quadratic function in a factored form, right? In order to understand more about that quadratic function in factored form, that is f of x is equal to a times x minus r1 times x minus r2. We are doing another example. So we have a quadratic function has zeros at -2 and 5. So what are the linear factors of the function? That is, given x is equal to -2 and x is equal to 5. Using these x values, which are the zeros of the function, I have to get a linear factor. Just the reverse process we will apply. Okay, I want to make this right hand side 0. So how can I make my right hand side 0? Just adding a number opposite of this. That is plus 2. -2 is opposite, plus 2. I'll add a 2 here. So what is remaining now? You have -2 positive to cancel out. So you are left with x plus 2, that is equal to 0. Similarly here, take away what? 5. That is, subtract 5 on both sides to give x minus 5 is equal to 0. Cancel this with the 0. So those are the two linear factors. What is the first one? X plus 2, you got one factor, and the second one is x minus 5. That's all. Linear factors. Now, can you determine the function? If so, write the function. If not, say why not. Okay. Now what I'm going to do is, this is my quadratic function in the factor form. Alright, then I'll substitute the values here. F of x is equal, I want to plug in the values. So a, do I know the value of a here? Using just these zeros, -2 and 5, that's the only information we have. So I cannot talk about that a. Times x minus r1, that is, your r1 was the first value, that is -2. Negative of negative became positive 2. So I'll write x plus 2 times x minus 5. So this is your quadratic function in factored form. Now what is the value of a? That's a big question. We do not know. Therefore, we cannot write the function. So the reason is this, a value. I'll just take an example. Suppose if I take a is equal to 1, how your graph is going to be when a is equal to 2 or a is equal to -3. Different cases. Let me show you for your convenience and better understanding. Let me turn it on. Clear it, clear off everything. Okay, the first I'll write a, when I take a is equal to 1, it will be x plus 2, close, open parenthesis again, x minus 5. Hit the graph. This is your first graph you have. Just the window is a little down, that's all right. I'm looking at the graph. I just want to show you that we will get different graphs. Now, if you take a is equal to 2, so I have to type in 2 here. 2 times x plus 2, close the parenthesis. Now open the parenthesis, and what? X minus 5, close, hit graph. Your second graph is slightly different. Alright, let me Just take some values for y minimum. Just take 25 and see. Okay, so those two graphs are different. Why are they different? Because of the difference in the values of a. Now if I take a is equal to -3, your graph will be entirely different, like upside down. Let me show you. -3 times x plus 2, close and open, x minus 5, close, hit graph. See, this graph is different, it is upside down graph. Let me take x equal to, y positive value, also 25, and see the third graph. 2 and the third, right? Yeah, so the bottom line is this: the a values are changing the graph. That is, the function, you cannot tell exactly what that function is just by looking at the zeros of the given quadratic functions. I need to know the value of a. That is the whole thing about this particular problem. Okay, thank you.